Indian standard codes. Okay, so here you can see the some codes according to the Indian standard. So if we talk IS 269 2015, and it is uh, this code is applicable for ordinary Portland cement, and this is the sixth revised version of the Indian standard code. Similarly, if we talk about IS 383 2016, so in this code, the specification for coarse and fine aggregates from natural sources of concrete, and this is the third revision edition of IS 383 2016. Similarly, if we talk about the IS 456 2000, and this code is applicable for plain and reinforced concrete for practice purpose. And similarly, the another code is 1199 to 2018, and it is applicable for fresh concrete, means method of sampling, testing, and analysis. Okay. Similarly, the another Indian standard code is 2386 1963, and this code is applicable for aggregate for concrete. Okay. And similarly, yeah, Indian standard one. Yes.
पर मेरे में पीपीटी नहीं दिख रहा है सर।
सभी को दिख रहा है क्या? इसके अलावा?
यस सर, दिख रहा है।
तो आपका नेटवर्क इशू होगा बेटा संजय चौधरी, आप रिफ्रेश कर लीजिए, ठीक है?
घूम रहा है।
आपका नेटवर्क इशू होगा बेटा।
सर दिख रहा है।
ठीक है। Then the another Indian standard code is 1103 1999, and it is applicable for admixture of for concrete, and this is the first revision. Similarly, Indian standard 15388 2003, and it is applicable for silica fumes. And another Indian standard code is 16714 2018, and it is applicable for ground granulated blast burning slag for use in cement, mortar, and concrete. So while we design the concrete mix design, so that time we have required some Indian standard codes. So Indian standard codes means we will take some values. Okay. So similarly, here you can see the overview of major modification in IS 10262 2009. So 2009 is a part of Indian standard 10262 2009, and so after 10 years they will revise the Indian standard 10262 2009 to 2019. So here you can see some minor difference between 10262 2009 and 10262 2019. So 10262 2009, the scope of this standard was very limited without giving due consideration for many factors and recent development affecting for the concrete mix proportion. But in the revised Indian Standard Code, the scope of the standard has been enlarged to include different types and grade of concrete, giving due to consideration to various other important factors. Similarly, this code is applicable for M65 to M100, SCC, and mass concrete. And initially, data to provided for mixed proportions has been made for N compassing by including provision of IS 383 2016, means uses of admixture. Similarly, for formula of target mean strength now has been redefined to include new factor based of grade of concrete, so as to ensure minimum margin between characteristic strength and target mean strength. Similarly, calculation of standard deviation has been detailed, and the graph between water cement ratio versus 28 days compressive strength has been introduced for OPC, TPC, and PSC for assuming initial water cement ratio. Similarly, the standard was applicable only for ordinary and standard grade of concrete up to M55. अभी मैं क्या बोल रहा था कि जो हमारा IS 10262 2009 is applicable up to M55 grade of concrete, but according to Indian standard 10262 2019, the grade is vary from above M65 to M100. Okay, so guidelines for uses of water reducing admixture has been introduced. Similarly, consideration of air content has been reintroduced in the design of normal concrete mix. Then, if we talk about some major modifications made in revised 2019 version, so the first Indian Standard Code was published in 1982. Then 2009 is the first revision, and the 2019 there is a second revision of Indian Standard 10262. So the standard has been divided into 5 sections. Means the general. Second thing is ordinary and standard grade of concrete. Then high strength grade of concrete, self-compacting concrete, and mass concrete. So here you can see the graph between water cement ratio and 28 days compressive strength of concrete. So free water cement ratio versus compressive strength. If the water cement ratio is 0.65, then the compressive strength for curve 1 is 60. Similarly, for curve 2, 70 Newton per mm square, and the curve line 3 is 80. So here you can see the water cement is increased. Similarly, the compressive strength will be increased. So if we talk about the grade M65 and above, means high strength concrete. So the first thing is impact and crushing value. So it is not less than 22%. The combined flagginess and elongation index should not less than 30%. Normal MSA less than or is equal to 20 mm for up to M75. Nominal MSA preferred 10 and 12.5 mm for M80 and above. And the fine aggregate coarser size is preferred zone first or zone second. So these are the some parameters related to coarse aggregate. Okay, so impact and crushing value. So while you studied in the fifth semester, so you have transportation engineering, so that time you will perform the aggregate impact value and the aggregate crushing value. Similarly, flagginess and elongation. So flagginess, elongation, and impact, it means the shape and size of coarse aggregate. So one more thing I already explained in the previous lecture, the workability. So workability of concrete is depends on the water cement ratio. Similarly, shape and size of coarse aggregate, specific gravity, okay, and the fine aggregate. So at that time you all are just seeing 2 or 3 things. First thing is segregation and bleeding. So don't be confused. So these are the some high strength concrete air content standard. Uh, so this is the first table is denoted for standard concrete. The another thing is high strength concrete. So here you can see the approximate air content accord in clause 5.2. Similarly, table 6 approximate air content clause number 6.2.3. So here you can see the nominal maximum size of aggregate is 10. So the air entrapped air as percentage of volume is 1.5. Similarly, if we talk about the size of uh, grade of size of aggregate is 20, then entrapped air is 1. Similarly, grade size of aggregate is 40, then entrapped air is 0.8. But in the for high strength concrete, here you can see that the size of aggregate is 10, and the entrapped air as percentage of volume, of course, concrete is 1, 0.8, 0.5. So here you can see the difference between standard concrete and high strength concrete of air content. Now, so these values are fixed according to Indian Standard Code. Similarly, selection of water content without chemical mixture. So this is the standard value is given in the Indian Standard Code. So water cement content per cubic meter of concrete for nominal mixture maximum size of aggregate, and this is according to clause number 6.2.4. So here you can see the nominal maximum size of aggregate 10, maximum water content 200. Similarly, 12.5 water content, maximum water content is 195. If the size of a course aggregate is 20, then the maximum water content is 186. So water content corresponding to saturated surface dry aggregates. So these are the some notes regarding selection of water content without chemical admixtures. Then the another thing is water cement ratio. So, means to selection how to selection water cement ratio for high strength concrete. So according to clause number 6.2.5, so target compressive strength at 28 days is 70, and the water cementation material ratio for 10 mm size of aggregate is 0.36, 12.5 0.35, and 20 mm 0.33. So here you can see the size of aggregate is minimum, then the water cement is maximum. Similarly, the target compressive strength is 100. So here you can see the nominal maximum size of aggregate, then the water cement ratio 0.26, for 12.5 0.25, and 20 mm course of aggregate is 0.24. So so calculation of cement and cementitious material content. So the clause has been made more elaborate to take into consideration the uses of multiple uh, SCM, MA like flaggy aggregates, gravel waste, SF, and other for part cement replacement, and it has allowed for increase in cementitious material content under such conditions based on experience or by 10% of preliminary trial. Then the limits of addition of flaggy aggregates GGBS are kept open based the project requirement and the quality of these material. Similarly, if we so high strength concrete recommended doses of 4 chemical mineral admixtures. So the first thing is fly ash, ground granulated blast furnace, metacoulin, and silica fume. So FA, GGBS, SF, and MK. These are the short name of some mineral admixtures. So according to Indian standard, the clause 6.26, if we add fly ash, so the percentage recommended doses percentage by mass of total cementitious material 5 to 30% means अगर suppose that आप अगर 300 kg सीमेंट ले रहे हैं, अगर उसमें आप कोई मिनरल एडमिक्सचर ऐड कर रहे हैं, so you can take 15 to 30% of cement. Uh, if you take fly ash, similarly ground granulated blast furnace slag, so you can take 25 to 50% of cementitious material. Similarly metaculin 5 to 15% and the silica fume 5 to 10%. So these are the some recommended doses of mineral admixtures material for high strength concrete. And if we talk about the coarse aggregate, then this table is shown in the volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate for water cement and water cementitious material ratio of 0.3. So it is shown in clause number 6.27. So here you can see the maximum size of aggregate, and then these are the zones, zone first, second, third. So according to size, if our size of aggregate is 12.5 and the uh, coarse volume aggregate is situated in zone second, so you have to take 0.56 value. If our size of aggregate is 20 mm and zone first, we can take 0.64. So these according to while we design, so that time you you all are we means the whole data is given to you, then you can take the value from Indian standard codes. If we talk about self-compacting concrete, so it has been divided into different classes based on slump flow, segregation resistance, and viscosity for different area of applications. So typical range of mixed constituents: fines content particle is less than 1 to 5 microns, 400 to 600 kg per meter cube. Fine aggregates content 48 to 60% by mass of total aggregate. And if we talk about the water content, that's 150 to 210 kg per meter cube. So now I'm discussed the guidelines for concrete mix design as per Indian Standard 10262 2019. So this is the some steps involved uh, while we design mix design. So you can take the screenshot of the steps. So the first step means data required. So while you design means M30 or M35, M40, M55 and above. So first of all, you must have data. Then you can determine target mean strength. So target mean strength, there is a formula. So by using that formula, we can determine target mean strength. So target mean strength means uh, if suppose that you want to design M30, so the target mean strength is above M30. Then so by using the formula, in the next step I will show the formula. Similarly, we can determine water cement ratio, then water content, then cement content, and coarse aggregate proportions, fine aggregate proportions, and ingredients per unit volume of concrete. So these steps are involved while we design a concrete mixture. So in according to step first means data required for concrete mix design. So concrete so concrete mix design. So the first thing is grade designations. So grade designation means आपको कौन सी ग्रेड की रिक्वायर कौन सी ग्रेड के लिए आप डिजाइन कर रहे हैं. Suppose that M30, M35, 40, 45, 50, 55, 60, 65. So grade designation. Then type of cement means which type of cement you have used. OPC, PPC, high slag furnace. Then size of maximum nominal size of aggregates means the size of aggregate you already uh, shown in your question. Similarly, minimum water cement ratio, then maximum water cement ratio, workability, exposure condition according to Indian standard 456, table number 4 and 5. Then maximum temperature of concrete at the time of placing, method of transportation and placing, early age strength requirement, types of aggregates, maximum cement content, admixture requirements, and doses. So you must have that data while you design concrete mix. So that time you must have these points or these data. Similarly, according to step second, test data for material. Okay, so means the first step is cement, the types and specific gravity. So specific gravity definitions I already explained in the previous lecture. Similarly, pliers, the specific gravity is also given in your question. Then type coarse aggregate, specific gravity of coarse aggregate, water absorptions, free surface moistures. Okay, then the fine aggregates, specific gravity, water absorptions, free surface moistures. Similarly, sieve analysis and chemical admixtures. So these are the data for material according to step third. Step second. So so according to Indian standard 383, I already explained about the Indian standard codes. So Indian standard codes are different of different material. Cement का अलग है, coarse aggregate का Indian standard अलग है ना, fine aggregate का Indian standard अलग है, Indian वो IS कोड अलग है. तो ये सारी चीजें. So according to size, here you can see the IS sheets 4.36, 4.75, 10, 12.5, 16, 20, 40, 63, 80, and the percentage passing for a single size aggregate of nominal 100. If the Indian ISC 80, then the 63 mm 100. Yeah? So according to the table, we can take the value. Similarly, the grading limit of fine aggregates. So these are the some grading according to table number 4, Indian Standard Code 383. So by using Indian Standard 383, you can take the value according to grade, zone grade. So next, so the next step is target mean strength. So target mean strength is an important part. Means here you can see the diagram. F dot ck is equal to fck plus 1.65 into s. So this is the formula according to 1026 to 2009. But the Indian Standard Code is revised in 2019. So by using that formula, that code. So the formula is f dot ck is equal to fck plus x. So here you can see f dot ck is equal to target mean strength at 28 days in Newton per mm square. So fck is equal to characteristic compressive strength at 28 days in Newton per mm square, and s is a standard deviation. So s value you can take with the help of Indian Standard 456 2000. Similarly, x is the factor based on grade of concrete. Refer table number 1. So table number 1 and table number 2. So that value you can take from the Indian Standard Code. So don't be confused, sir. ये table number 1 और 2 क्या है? ठीक है? So according to table number 1, clause number 4.2 said here you can see the value of x. If you design M30, okay, grade of concrete, so that time you will take the X value is 6.5. So if similarly M30 to M60 you can take 6.5. So M above M65 to M80 you can take 8, the value of X.